Alright, hello everyone and welcome to this video. So here we're given a valid parenthesis. That means if every open parenthesis is closed, then the whole code is valid. It's the case of programming. When you open a parenthesis and you don't close it, it's supposed to give an error. So like in this case, you open, you close, you open, you close, open, you close, fine. But you open this one and you close something you have not even opened. This one is always supposed to give an error. So I once did that in C, but I did that using a stack. I had a stack pointer and I created a lot of methods. It was really long. It took a lot of time. It took me almost 2 hours to do that in C. But in C sharp, there's already an object called stack. So which I'm going to use. Stack. It's in system collection generic as a class, and here stack. So what am I do with the stack? I'm going to go through this list. If I meet this guy, I push him onto the stack. If I immediately after I meet something closing him, I go and remove him from the stack. At which point the stack becomes empty. Like here, push, remove, push again, remove, and push, remove. Yeah, I'll push, but when I don't see anything closing, so I push again. In the end, I'll go through the string and there will be an open and a close, but nothing. The stack will still have elements because I've not popped anything from the stack. And at the end, I'll check if the stack still has elements, then it's not valid. But if it does not have, like if it's empty, that means everything I pushed, I popped from it. Now, now that I have my stack, I'm going to use a for loop to go through my array or my string. Now, let me just expand this so that it's clearly legible. And so I have my for loop. Now I'm going to say if we are the first element, so if you are the first element, let's say point push, just push this onto the stack. Now I'm going to try to defend against this defensive programming, defend against the situation where the string is empty. So it's equals to 0 to this. True, just return true. If it's an empty string, that means everything is fine with it. Now I'm going to push this. I'm going to move to the next iteration. So don't do anything that is coming next. Just go to I equals to 1. Now, if now, in this case, Si, if what I am on is a closing parenthesis, or if what I am on is closing anything, or it's a closing parenthesis, or it's a closing bracket, or it's a closing square bracket, okay? I don't think they had angle brackets in that thing. So if all of these are closing, okay, if all of these are closing, now I start verifying. I enter here and say, okay, if in the first case I was closing this, Control C, Control V. If I'm closing this and the last element of my stack, I get it by stack using stack point pick. It's going to give me an object. But I want to say if it's equal to this. If I'm closing and the last element of my thing was I was opening it, like if the one that I pushed before was just opening parenthesis, then I'm closing. I'm supposed to move this guy from the stack so that the stack becomes empty or the stack does no longer have him. So I've handled both of them together. The stack point pick will tell me an object. I'll cast it. I'll do a typecast to produce character. So if this is the case, then remove the last element from the stack, then continue. I'm going to repeat this move in the other bracket cases. And then the final case. Now in this case, I'm going to change it to this. If I'm closing, but in the previous iteration I was opening, still here, if I'm closing the angle bracket, oh sorry, if I'm closing the angle bracket and the previous iteration I was opening it, then I'm going to move what is on the stack. So if this guy, if in the previous iteration this guy was the one on at the top of the stack, then I put close. I no longer want to deal with him again, so I'm going to move him from the stack and not even push this guy. So in the case where now none of those are true, so that's if I am opening. So if this does not happen, and this does not happen, and this does not happen, so what do? I want to just push to the stack. So let's push. What am I pushing? Well, if this does not happen, then I want to leave this parenthesis, and to go out, and I do st point push. I'm pushing si. Okay, that's what I want to do. Let me just minimize this and look at it. So what do I want to do? So that's if in the case I'm closing, then in the case I'm closing when I am, how do I call it? I already open. I want to pop from the stack, then continue to the next iteration. That means come back up here. But if in the case, if I am not closing, that means in the case I was opening, then you just keep all of this if. I think this is the if. This is the if. Yeah, in the case of opening, you'll skip the whole of this if block. This if block here. Can I simplify? Yeah, it's going to skip the whole of this block and just push it. Then now, if I was closing, it's going to come to this if block. I was going to say, okay, if I was closing after having opened, then pop. But if I was closing, meanwhile I opened instead this one, then you'll not do anything. You'll just skip all of this. And you'll go back to this push. That's it and done. But now this peak, I see a problem. This peak cannot work on an empty stack because it's not an empty stack has no element. So I'm going to make sure the stack has an element. So if these are true, and stack point counts, that will give me a number of elements in the stack is greater than 0. If the stack has at least one element before it does this. If not, this peak method will not work. Push and pop can work on empty stacks. The pop cannot work on an empty stack, so it also protects this pop. Now what am I going to return? So I'm going to return with a condition. If stack point counts is equals to 0, return true. If not, return false. That means if there's still an element on the stack, that means if I don't handle all of them, return false. If not, return true. Let me collapse this, maybe shrink this. And I'm going to run this. Hope everything is correct. I hope I've made no errors. Okay, all the cases run true. Let me try and submit. They're going to hit it with so many test cases. If there's a test case that does not work, I'll have to take it and retest it. Okay, that one worked correctly. That was easy. I beat just 50% of people in speed. I'm using C#, so it's not C. and I think it's fine. I think the solution is submitted. Okay, that's all I have for you in this video. Thank you for watching, and see you on the next one.